Today, we are going to talk about the best thing since sliced bread. It's concurrency in NSO, and more specifically about observing it. I'm Kristian Larsson from the Cisco NSO CTO team, and today we are observing concurrency. Unless you've been living under a rock for the last half year or so, you've probably seen the NSO 6.0 release. And there's a couple of new features in 6.0, but without a doubt, the one that I think outshines them all is the introduction of concurrency. We've had some concurrency in NSO previously in device interaction, etc., but this brings it to the very core of NSO through optimistic transactions. Having been around for over a decade, NSO is a mature product at this point, and I think it makes it particularly impressive to have done the equivalent of an engine replacement, on a space rocket, sort of. But we're not going to talk much more about the details of concurrency in NSO. There are longer and much better talks on that subject already. The marketing material for NSO 6.0 frequently mentions 3 times to 9 times improvement in transaction throughput, depending on what the workload looks like. Together with you, I want to dig deeper into that. I want to peel back the different layers of what we have to work with, and just when can we expect a 3 times improvement or 9 times improvement, or maybe something else entirely, right? Obviously, the mentioned numbers, they're generalizations, which are really quite hard to do in a software-intensive system like NSO. There are so many degrees of freedom that it's very difficult to generalize over different NSO deployments because of that flexibility that you have. So the best way to answer what throughput gains you can have in your system is simply to measure on your own system. And that is what we're going to talk more about here today, right? So I think that equipped with knowledge of NSO concurrency, some proficiency with these observability tools that I'll show you here today, together with the data that you'll grab from your own NSO system, you'll be able to answer these questions for yourself with really quite some precision. So on the observability tooling front, the NSO observability exporter package, which has been around for a couple of years now, coupled with an off-the-shelf observability stack, that is going to be our workhorse. There are primarily 2 views that we get into our data on 2 different zoom levels. So using metrics, we get a zoomed out perspective, an overview of our system and how it behaves. You can, we won't be able to see details, but we can get a lot of data, like many transactions or operations, also spread over time, and we can get all of this into a compact and quite intuitive view, right? A graph. And if we need to drill down and group the details of individual operations, we can do that. We can zoom in. We have this trace view, which shows typically it's a visualization of a single transaction, and we then get the details of that operation and can understand its behavior. And in this presentation, I'm going to show you a new view that we have. It actually renders to a terminal, so it's a sort of a text user interface. And if you're like me, it'll have a special appeal to you. But more importantly, it can render a detailed trace view. We're going to be able to see multiple traces in the same view, and we can follow the system in real time as it is progressing and making operations, right? So it's really quite neat, I think. It was actually a colleague of mine, Ulrich, who completely nerd sniped me here a couple of days before I was supposed to record this video. He showed me a proof of concept of this sort of graph view. So after that, I just had to put this into the observability exporter package. So thanks, Ulrich. I think it ended up a lot better than it otherwise would have. Okay, so we're going to start to look at NSO 5.8, which will be representing the era of NSO before we had service concurrency, right? So this is NSO 5.8.5, I think. Let's see here. Yep, 5.8.5. And I'm just going to run a simple transaction. So I have this, it's a service, it's called slow service. It's just sort of an artificial service. We can create an instance of that. Looks like that, right? Commit, dry run. Doesn't really do much. It writes, actually it doesn't do anything, right? So let's commit that. We can look at the progress trace output by doing this, right? And we see that the entire transaction the entire transaction completed in just 41 milliseconds, right? So there are two input options to this service. There's a create slowness, and this takes a decimal number, and this is the number of seconds that it sleeps in create. So let's just do 1, and we commit that again with pipe details. So we get the progress trace, and voila, now we see that it took just over a second, right? So adding 1 second of sleep added, well, a second to the entire transaction roughly. There's also another 10 milliseconds, but there's some variation here, right? And we can see here actually that you know, this is in the service, right? And it actually tells us here in progress trace that it sleeps for about a second. There's another option there as well. That's random create slowness. So if we do 1 here, it sleeps somewhere a random time between 0 and 1 second, right? Or if we do 2, it's between 0 and 2 seconds, right? So we get some variation. Okay, so I'm gonna show you a different view on this, right? So let's just jump over here. So all of this is based on sort of the NSO and Docker style of development. So there are containers doing all of these things, or running NSO, etc. So doing this, I get a shell inside of the container that's running NSO. So we can see here, you know, we have, this is the NSO process and a bunch of Python VMs, etc. Right? And in this particular environment, I have this alias ptrace set up. So this is ptrace is one of the files in the observability exporter package, right? So besides being an NSO package that you can run that exports the progress trace data from a running NSO instance to, you know, observability and observability stack, we can also run the ptrace. This is like a command. We can use it for batch processing, and in this case, we're gonna look at the help options for it. It has an option called live. So live, what it does is that it attaches to the IPC port of NSO and subscribes to notifications, so we get data to us live. And then we're going to combine that with Rich Graph, which is this new trace visualization that's happening right here in the terminal. So at the very top here we have the NSO CLI, okay, and then at the bottom here we have the trace view. That's gonna, well, let's see what happens, right? So we can just change that slow service that we had, and I'll commit that, and bam, we got us some data, right? So what we see here are now, this is well, we just did 1 transaction, right? So this shows 1 transaction. We can see here actually that the top, the first span, all of these that are listed here, these are spans. So the top span listed here first, this is the transaction, right? And we can see applying transaction, and then there are the different phases in the transaction, like validate. We have further down where you know, prepare and commit, etc. Right? So these are different, you know, like phases, and then it gets more detailed. And over here on the right side, this is now the graphical part of this, right? So this shows us the length here represents the time we spent in this span. So we can, that it took up, right? So the transaction naturally spans the entire thing. We see applying transaction. That is the actual operation of trying to commit. We could have actually multiple applying transactions spans going on. In case, for example, you have a transaction, you try to commit it, but it fails. That's a failure on the first applying transaction. Then you do it, correct the error, and then you do another applying transaction, right? But anyway, we can see we spend most of the time in the validate phase, right? This is a holding transaction log for the entirety of the time. And then we come down here, right? And it's really this one, like, I mean, it's usually the bottommost span that's long. That's sort of where we are spending our time. So sleep configured time here. Not very surprisingly, right? We asked it to sleep for half a second, and it takes 501 milliseconds. So that is where we're spending time. I'm gonna adjust this view slightly. So what we can do, there was another option here, filter span name RE, and I can enter a regular expression here that will filter on the names of spans. And let's see what we get here. Okay, so now we get everything that has the transaction in the name, right? I'm actually gonna let's do like this, right? So we want to see just the one that's transaction. That's that. And then we also want to see the, let's say, holding transaction lock, right? Okay, so, and then do another transaction. And voila, now we get that, right? So, and just to show you now, so let's do another transaction with the trace view still open. And we can now see that we get, well, you see there are two different transactions at different timestamps. And let's do a third one. And there's it's a little hard to see here, but there is a slight color variation between the transactions here. I think we're a little bit unfortunate here. The, the variation is actually very low. But you know, as we probably because it iterates over something, so they end up close to each other. But anyway, we can see that, right? And now all of a sudden, so this trace view, it tries to show us as many rows as the terminal is high, right? So that then sets the time span that we're going to visualize in total. So I'm going to back out of this. Okay, so we'll just restart that so we get a fresh, clean slate. And then we're going to do, so I have this make targets, a couple of different make targets prepared. Test concurrent is going to open up a number of transactions. They're just going to spawn sort of in parallel. It's going to open through the NSO CLI and just apply a number of different transactions and for services. And so I'm going to run that and let's see how that looks, right? So what's immediately visible, right, is that there are way more transactions here than we have space to visualize. So, you know, it just goes off the screen, right? Maybe I can actually zoom out a little bit, I think. Yeah, I can do that. So maybe we won't be able to read the text, but you can still, I mean, I think the important part here is the visualization. That's what we're going to look at, right? We can see that the bars here are sort of, they're shrinking, right? This is because this is updating in real time. So we're seeing as these are as they're progressing, right? Each individual span. And each of them is 2 seconds long because we've asked each of these in each transaction. We're creating a slow service and we've set, you know, the slowness, the create slowness to 2. So it sleeps for 2 seconds. And that is in this column, right? We can see the length of the span in milliseconds. So there are 2050 something around there. It's about 2 seconds. And we can just, I mean, it's just obvious, right, that we have serialization going on here. You complete one holding transaction lock, and then you release the transaction lock, you hand it over to the next transaction, and so on and so forth, right? So this is what it looks like in NSO 5, and well, let's not stick around for this, right? Let's jump into NSO 6 and see what it looks like. Okay. So I'm going to stop the environment here. We're going to set NSO version 6.0 and then do a make start to start our topology. I'm going to quit this and do the same thing there. So it's not a problem. We can run multiple of these environments in parallel. It just takes a tiny moment to start up. Okay, so the NSO 6.0 environment is up and running. I'll just show you that this is indeed NSO 6, right? And then this is actually, it's running in parallel, right, to the other thing. And then we got the ptrace command again, right, which I just wrote down here. So let's start that. And yeah, let me zoom out. Okay, and then let's rerun this concurrency test and see what it does. Okay, so sort of the same pattern, right? Okay, transactions, you know, we saw it opened all of those transactions sort of at the top, right? And then we got the holding transaction lock, and we still see this pattern, right? It's still serialized. There's just, you know, a single one running at the same concurrently. But some things change, right? I mean, we can see that the test, it's already completed by now, so it ran much, much faster. What is going on? Well, what happens here in NSO 6 is that the service code is no longer running under the transaction lock. We still have a transaction lock, so we still get serialization, and this is required for the strict consistency that we have in NSO. NSO contains a database. It's Yang modeled, and Yang has a very flexible and powerful constraint model. So you can enter these constraints into your data model, and NSO honors those constraints, right? So with that as a base, we really can't get away from having sort of a serialization going on. This is not an eventual consistency database. I mean, in other databases, you could commit things that just, they're not consistent, and the databases, they don't support enforcing those kinds of consistency constraints. But NSO does, and that's why we need this. But what we see, right, is that it's so much faster. And this is because all the service code, it's been moved outside, so it's no longer running under the transaction lock. So the sleeping of 2 seconds, we can do that ahead of taking the transaction lock. We compute we run this, we compute the diff set, and then when we're done with that, we grab the transaction lock, we run a conflict detection to see if our transaction has conflicts with any other previously running, right, or that has now applied to the running configuration. And if not, then we just apply it and we can move on. Let's take a look at another visualization. So if we have this where we selected out, we filtered out the transaction and holding transaction lock spans, right? Instead, this time around, we're going to look at create. Okay, so we can first, I'll just remove that. We'll run a single transaction. It actually ends up being 2 transactions because the first one deletes any existing services, and then we recreate one. So let's see here. We have the create span down here, right? Sort of in the middle. Let's see if I can show you that right here. Okay. So we're going to visualize just that. So we filter span name RE like that, and then let's rerun that concurrent test. And this is what it looks like. So the spans that are red, those are currently ongoing, right? So you can see that they're shifting from red into their real color, sort of, that aligns with the text on the left side. That is the color that's sort of assigned to that particular transaction, right? And here I think we see much more clearly, right, the sort of the pattern that we had before, right? That it grabs a number of services and run they don't start exactly at the same time. I think this is just in my test script. It's a little slow starting up, sort of, so it's an effect of that. So we can see there's a sort of a gradient here. It starts up, but then they're ongoing, and in this case the create is very close to 2 seconds because that's the time it's sleeping, right? And when they're all done, I mean, you can see that the first one, when it's done, that aligns quite well with the last one, when that one in the next here. Actually, it seems to start a little before. That's surprising. I'm not sure why. That might be a graphing display. No, actually, I guess it's because there might be transactions ahead of this that we don't see on the screen. They're scrolled out, right? Yeah. There we go. Right. I zoomed out. Okay. So we see that the first one, the very first one, yeah, that aligns with the first one. When it ends, it aligns with the start of the first one in the second batch, right? So in this case, we have a service that's doing sleep. That is obviously not something that you would do in any real service, right? I'm just using that here as a stand-in. It's a sort of a placeholder of a service that would do really heavy work, heavy computations, or maybe it would actually go out and ask other systems, right? So there's an API on an IP address management system or something else, and we talk to that system and communicate, right? And that will take time. So this could be seen as a sort of a placeholder for that, right? And one of the reasons, I mean, if you consider the number of schedulers, the number of services that we take on and process at the same time, it's the same as the number of CPUs in the system. And this is because we assume that most services are going to be CPU bound. We don't think that we're going to be waiting on IO, for example, right? Because that is not the typical case. So if you do, I mean, if your services rely on network IO a lot, you talk to other APIs and there's some latency involved in that, right? Then you're going to be waiting most of the time, and you're going to see quite a low CPU utilization. NSO is just not going to be able to utilize all CPUs for you, right? But again, that is not the typical case. The typical case is that, you know, it's service create code and we're doing computation inside of Java or Python, and then you're feeding this into NSO, you're applying templates, and then we're gonna, you know, see CPU usage based on that, on applying templates, right? So yeah, I mean this is overall a pretty solid foundation, right, for doing concurrency. The next thing that we're gonna look at and touch upon is the concept of conflicts, right? So what these concurrent transactions that you get in NSO 6, the way it works under the hood is that we sort of assume an optimistic stance, right? So these are called optimistic. It's called optimistic concurrency. So essentially what we do is that we assume that a transaction is going to be able to apply. So we proceed with it and progress as far as we can. While the transaction is progressing, we record everything that it's doing. Okay, so the right set of a transaction is the output of the transactions. So it's fairly natural. I mean, we've always recorded that, obviously. Otherwise, we wouldn't have a result of the transaction. But now we also keep track of the read set. So we see all the things that a transaction reads, and two different transactions, if they read the same thing, that's completely fine, right? Because they haven't modified it. So both are going to see, I mean, if it's a simple, like it's an integer, a leaf that has the value of 3, if both transactions read this value, they're both going to see 3, and so they don't conflict in any way, right? But if one transaction reads this value, and then we see another transaction that changes this value, it updates it, right? Then the result of the first transaction might be invalid because that value that it read has been changed before it got to apply its changes. So this is the basis of the concurrency in NSO, and we call it optimistic because we assume that we're going to be able to apply at the end of the transaction, and that's when we do the conflict detection to see if there are actually conflicts. And at that point, we determine, okay, there's been a conflict, so let's rerun this transaction. And in NSO, we have this concept of what is the intent, right? What was the information that came in with this transaction that the user tried to apply. And so retrying a transaction just means that we use that same intent, and then we try to run the service code to produce some output, but now with the updated values, right? So we're going to bring up the trace view again, and we're going to limit it to the create spans, nothing else, to keep a simple graph. And I have this make target concurrent 5, which much like the early ones we've seen, this runs a couple of creates concurrently, but this one limits it just 5, so we get a simpler graph to look at here. So this ran just fine, right? If we quickly, actually, let me do that in a bit. I'm going to show you the service code. It has an input option that makes it either conflict or not. And in this default mode that we're running in it, it's not going to conflict. And that's why we can see this. They're all running concurrently, right? And we can run that again, and we'll see, we get 5 new transactions here running, and etc. Right? So this is seemingly working all right. Now I'm going to switch over and run this other target that sets the conflict option, essentially, so that it is going to conflict. And I'm going to restart the trace view here just to make the output a bit clearer. Okay, so we run that, and we see that all 5 transactions, they start off at the same time. Okay, but what's happening now, right? We're seeing lots more create here, and this is the transaction retry in effect. So out of these 5 transactions that we started at the very start, right, only one of them is going to succeed. The other ones, NSO is gonna realize we had conflicts, and so it is going to schedule these to be retried. So they're sort of like they're queued up essentially. And as NSO, as it realizes that these have conflicted, it's not gonna retry. If you at first had 5 transactions, we got, one got to apply, 4 had conflicts. We don't do a retry of all 4 because then one would get to apply, the 3 others would conflict, and you get to rerun it. And if you apply 100 services, it becomes a lot, like 199, 98, etc. So it takes a real long time. But NSO realizes this and sort of backs up and just starts queuing them up instead. So there's a new lock introduced that helps us do this. And this is exactly sort of what we can expect, actually, that out of the 5 first, only 1 got to apply, and then the other ones got queued up. So if we look over time here, we'll see that we got the first group, that's 1 there, 2, 3, 4, and 5 services got to apply, but they ended up running in sequence. Okay, so I wanted to give you a view of this service and why it conflicts. So here's the code for the service. This is the create function, create callback. And we can see that early on here, we're gonna check this service.count, which is an input option to the service. And if it's set to true, we're gonna attempt to increment the counter. So the first thing we do is that we read out the current value from root.counter. So root.counter is it's really a global counter, right? This is not per service, but it lives at the very top of at the root of the NSO database. So we're going to read out the current value, then we're going to proceed doing that sleep that we're asked to do if there's a create slowness or random create slowness set. And at the end of the create callback, we're going to increment this counter by just adding 1 to the current value. So if we run these in parallel, multiple service create gets to run concurrently, then this is bound to conflict, right? Because you just can't have 2 transactions that both read out a value and try to write back an incremented value. It's just gonna conflict, right? This is an obvious example, something you'd write as an example, which is what I've done here. In your code, if you're seeing conflicts, they're probably going to be a lot more subtle than this. But nevertheless, this is the basic shape and form of conflicts, right? You can look at your conflicts inside of the NCS CLI. They're under services and then scheduling. This is a hidden, so you need to do unhide debug first, and then show services scheduling, and we see that we currently have no entries found, so there are no conflicts that NSO has detected. So if we rerun, let's see here where we have, let's rerun those same, and there we go, we got some conflicts going. Okay, great, and I'm gonna back out here into the CLI again, and we can look at the same thing, and we see that we indeed have a conflict detected, right? So it tells you some of the, when was it seen, and this is sort of the back off, because we don't want to invoke it. It's essentially a denial of service on ourselves, right? If we just retry all services with no form of rate limiting, we're just gonna produce a lot of busy work, and most of these transactions, they're just going to conflict again and again and again and again, right? So that's why we try to back off like this. So this is one view. I mean, you can of course monitor this, the show services scheduling. I think it's really useful for development. For production systems, maybe not so much. You typically want a more systematic approach to monitoring this. You do have the data. It's available in the devel log. I think this is the same. So we can see here for example, conflict on. It tells us some information about where we found conflicts, etc. Right? So that's one way of finding them. I think the better method for this is essentially through progress trace. And that is what we're already exporting using the observability exporter, right? So if we quickly recreate that data we had, so I'm gonna rerun. Let me just bring up that in a graph view as well. We have these 5 transactions that are gonna conflict. So this is the exact same thing that we looked at before. And now we are going to let me see here. Bring this up in Grafana. So these are now the 5 transactions that we had. It actually shows 6 here because the first one is that, you know, it's removing, right? The timings are as we sort of expect here, since they're serialized after each other. And if we scroll down a bit, we're going to find another graph called service conflicts. So we can zoom in even further here, and we're going to be able to count and see that on this first one we got a count of 2, and then 1 and 1, so that makes up for a total of 4 conflicts. And this is because we had 5 transactions trying to apply. One of them goes through, and the other 4 gets conflicts. So this is a view of that, right? We can see here that we got conflicts. There's the graph view, and we also have a table. And here it shows, it includes the trace IDs. So we can see how this aligns. For example, the last one here's 1014 at the end. And if we flip over here, we're going to see that the last one here as well, it has 1014, right? So this is, it's the same information, just different views into it. So I think that for a production system, you're going to find that this kind of view that we get already with the observability exporter, that's probably going to be the best way to monitor a production system. And with that, I would like to wrap up. So please go and listen to some of these longer presentations that we have on the NSO 6 concurrency models. I think it's really good to have that understanding of the system when you're doing service development, as well as when you're operating your production environment. Look at the observability export and the tools that we make available, and above all, play around with the data that you get from your own system, right? You shouldn't just be looking at sort of ready-made examples, but you should be looking at the services that you use in your system, and hopefully you'll be able to observe some concurrency of your own. Thank you very much for listening.